Today we'll start exercise 5.3. This is the last exercise of the chapter data handling. So today's assignment is question number 1, 2 and 3. Now according to the first question, there is one spinning wheel is given, and on that spinning wheel there's some letters are written. Fine, and this is a pointer. This is a pointer given. Fine, this is a pointer. Now the first question they have asked, list the outcomes you can see in this experiment. That is, what are the total outcome you can see? So outcomes are what? A, B, C and D. Both A are there, but outcome is A only. So what are the total outcomes? A, B, C and D. So on spinning the wheel, the possible outcomes are 4 only: A, B, C and D. Either A will come, or B will come, or C will come, or D will come. These are the 4 outcomes of the wheel. Now tossing two coins together. Now suppose this is a coin. Now we know that in each coin we have head and tail, isn't it? So we have to toss a two coin like this at a time. At the same time we have to toss two coins together. So what are the outcome? What are the possible outcomes that we can have? So how to do that? See, imagine that this is a coin carrying head and tail, and this is another coin which is carrying tail and head. Okay, now what is the total outcome if you toss a coin? So what is the first outcome? Head. In this particular coin it can come head, and onto the second one it can come tail. Fine. So what is the tactics that you can get the total outcome? So you have to multiply it. See, head and tail, this head has to be multiplied with tail. Head and tail, this is the first outcome possibility. What is the second possible chances? Head and head, both the coin could have head and head. So H multiply. Fine. So multiplication with this H is complete. Now multiply with this T. Okay, so what is the other possibilities? That both the coin could have tail and tail. So TT is another possible. And what is the another possibility? Tail and head. So these are the 4 possible outcomes when we toss the two coins simultaneously at the same time. Fine. Either head tail will come, or head head will come, or tail could come, or tail head could come. So I have written T represents tail and head represents H represents head. So these are the 4 outcome possible when you toss the two coins together. Okay. So this is very, very important. Now let's move on to question number 2. Now what is question number 2? Question number 2 is, when a die is thrown. I hope you know what is a die. You must have played Ludo. Okay, so a small cubical thing is called die. So when a die is thrown, list the outcomes of an event of a getting a prime number. So we know prime number. These are some of the questions they have asked. How many prime numbers you will get? How many prime numbers not a prime number you will get? How many numbers greater than 5 will get? And how many numbers not greater than 5 will get? So see how I've started the answer. When dice is thrown, the possible outcomes are what? There are 6 numbers, isn't it? 1, 2, 3, 4, 5, 6. So among these 6 numbers, we have to answer all those questions. What is the first one? A prime number. How many prime numbers will get? 2 is a prime number, 3 is a prime number, and 5 is a prime number. So the prime numbers are 2, 3 and 5. So total outcome is 3. Not a prime number, the numbers which are not a prime number. So 1 is not a prime number, 4 is not a prime number, and 6 is not a prime number. So not a prime numbers are 1, 4, 6. So total outcome is again 3. Second, sum number A is a number greater than 5. So how many numbers are there which is greater than 5? Only one, isn't it? So the numbers greater than 5 is only one number is there, that is 6. So outcome is 6. Number not greater than 5. The numbers which are not greater than 5 would be 1, 2, 3, 4 and 5. 5 is also not greater than 5. So 5 would be also included. So 1, 2, 3, 4 and 5. So this is a solution of question number 2. Now in question number 3, the first question is related to the first question. Okay, the first part. Sum number A is related to the number 1 question. See, we have studied this dyna. So now this time the question is probability. Now how to find the probability? It's not only the outcome, but what is the probability? See, probability of pointing stopping on D. So this is a pointer. There was a pointer, isn't it? So if you just swing this wheel, okay, so how many times a pointer will point on D? So this is a question. What is the probability? What are the chances? So how started the answer? See, the pointer can stop at one of the following regions. That is, either the pointer can stop here, 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 either the pointer can stop here. So there is 5 chances, 5 output we can get. Okay, so A, B, C and D. In any of them the pointer can stand, isn't it? So out of these 5 cases, how many times D is there? Only one, isn't it? So out of these 5 cases, it is possible only in one case that the pointer will stop at region D. So it is, if you swing a wheel, then how many times the pointer will, how many times is possible that pointer will point on point D? It is only one time, isn't it? Therefore the probability will stop at region D is, out of 5 cases, that is, see, total number of 5 cases, how many times the pointer will point on point D? Only one. So the probability is 1 upon 5. Out of 5 cases, it will happen only one time. So this is probability. Now sum number B. Probability of getting an ace from a well shuffled deck of 52 cards. So you must have played cards, students. So I have just given some of the information regarding cards. So there are 52 cards in a deck of cards. Altogether there are 52 cards. Now altogether there are 4 sets of cards. In 52 cards there are 4 sets of cards. They are as spades, clubs, hearts and diamonds. These are the 4 sets. Each set is carrying 13 cards. Okay, each set is carrying 13 cards. Now each set carries only one ace. That is, spade will carry one ace, clubs will carry one ace, heart will carry one ace and diamond will carry another ace. Okay, so each set will carry only one ace. So how many ace altogether in a 52 cards? 4. So this is the question they are asking. So there are 4 ace cards in one deck of cards. Okay, in one shuffle of cards there are how many aces? 4. So the probability of getting an ace is, out of 52 cards, how many ace will get? 4. So altogether, that is total number of cards, that out of total number of cards, how many ace are there? 4. So this is the probability. So probability is always taken on the total number. Always taken on the total number. Number C. I have not drawn the drawing. You will find that in the question there is one circle is drawn. Inside the circle there are some apples are drawn. Fine. So there are 5 apples inside the circle. Okay. So I have not drawn the figure, students. So the question they are asking that there are, I have written, see, there are total 7 apples, out of which 4 are red. You will find that in 4 apples R is written. So out of which 4 are red, and in 3 of the apples G is written. So 3 are green. So altogether how much apples? 7 apples. Now they are asking what is the probability of getting a red apple. So out of 7 apples, how many times you will get? 4 apples. If you take one at a time, okay, suppose from the circle, if you take one at a time, so how many apples, how many red apples you will get? So out of 7 you will get 4 apples. Okay, out of 7 times, because their number of apples are 7, so you will take 7 apples. Fine. So when you're taking 7 apples, it is how many times that you will get 4 red apples? It is only 4 times it will happen like that. So probability of getting a red apple is, out of 7 only 4 red apples are there. So this is a required answer, 4 upon 7. So that's it for today. In next session we'll complete this exercise, that is 4, 5 and 6. Thank you, students, and take care.